All right, ready now. Good morning. Welcome. Today we're looking at activity diagrams again. On Monday, we all experimented with activity diagrams ourselves, and I trust that that was a good experience, a good learning experience. So moving on now, just some of the formal details that we need to know about activity diagrams. And next week you'll be using them in your tutorial session, your studio sessions. So activity diagrams allow us to specify how our system will accomplish its goals. Activity diagrams show high-level actions chained together to represent a process occurring in your system. When you're doing an activity diagram, you don't necessarily need to think about the implementation details so much. You don't have to think about your objects and messages between objects and so on. There's a diagram that we use for doing that, for showing the interaction between objects. Which diagram is that? In fact, there are two diagrams. Now, the class diagram. No. So object diagrams and class diagrams, no. Object diagrams and class diagrams are structural diagrams, and they show us in a static sense how these different entities are related to each other. But in terms of interactions during runtime, we want to talk about that. We use sequence diagrams or communication diagram, and you'll see that soon enough. So as I told you, interestingly, activity diagrams can also be used for business process modeling. And what we're going to do is to go through the details of activity diagrams. We're going to look at we're going to look first of all at the create of new blog accounts use case that we looked at last week. We're going to look at how we would flesh that out in an activity diagram. Now remember, an activity diagram is another way for us to specify the how of a use case. Remember, we said that use cases only tell us what, but we can use a narrative to tell us how, and we can also use an activity diagram. The reason why activity diagrams are beneficial in this sense is that sometimes where somebody will look at a whole specification and not follow exactly what's going on, usually people can look at an activity diagram and have a good sense of what is happening in a particular use case. Does that make sense? Because an activity diagram is like a flowchart, and everybody knows what a flowchart, how flowcharts work. So let's take a quick look at this, and somebody can just take a quick look at the next slide. That's slide of the activity diagram, and somebody can quickly volunteer, whether you're online or in the room, volunteer to say what is happening. And a lot of notes on the slide. So we're first passing our initial node, right? And we're also seeing an arrow or an edge, right? An activity diagram is essentially like a graph, so we can call that arrow an edge. It represents a flow, an activity flow. It does not generally, although I will show you later on how you can do that, it doesn't generally tell you that data is being passed. It just tells us what is the next activity, what's the next action to take in this particular activity. The next thing is an action, and this action says ask system to create new blog accounts, right? That would have been the first step that initiates that use case. Now actions are represented by squares with rectangles with rounded edges. Everybody seeing that? Next, we have another edge, and that points to the next action in the activity, which is select account type. Then we'll move on to enter author's details. Then we'll move on to verify author's details, and then we see our diamond. And the diamond is used to indicate that a decision needs to be made, that something has to be checked. And when you do flowcharts, we tend to show the text or the question inside of the diamond. You can do that in activity diagrams as well, but the most common thing for us to do, according to UML standard, is really to just put the diamond there, don't put anything in it, and put the conditions along the pathways that come out of the diamond, that exit the diamond, right? So another approach is for you to put a question in the diamond. So in this example, you're seeing authorized and not authorized as two conditions that represent possible flows or alternate flows exiting the decision symbol. Another option is to put inside the diamond, check for authorization. And then the two branches would have, in square brackets again, true or false. All right? And we say that if the author's details are authorized, then we have create new blog account, email blog account summary to author. And on the other side, if it's not authorized, we say that the application will be rejected. And then they meet together in another diamond. What's that diamond called? That's a merge. So you have decision and merge, and all decisions usually come together at the end into a merge. And then we have our final node. Making sense so far? All right. Now, relationship between activity diagrams and those boxes is inside. The activity diagram represents a complete activity. The steps within the activity diagram, that is the statement, the rectangles with the rounded edges, they're called actions. So activities are made up of a sequence of actions. Or actions chained together, as we saw in the definition. So you're seeing here a wash car activity. So wash car is the activity. And the actions are lather, then rinse, then dry. And then there's a final node. Notice that there's a frame around this activity. You generally don't always have to put the activity, but if you generally don't always need to put the frame. But if you hope to reuse this activity in another activity, which you'll see later, then you need to put that frame so you can name the activity explicitly. Then call upon it known activity. So this is an activity, right? Can you see the slides? This activity, wash car, it has some actions in it. But you can treat this activity like an action in another use case. In another activity, you can reuse it. So you put the frame around it, and then use it later on how you can reuse it. Any questions? Yes.
After a decision, do you always have to merge?
That's actually useful. Go ahead.
After a decision.
Mute your microphone. Just mute your microphone. Yes, you should merge. Let me tell you the cases where it are. So the question is, if you always have to merge after a decision, you really should bring those paths back together. But primarily, this is important if the activity consists of other actions later on in a sequence. And if it is that, so sometimes you will not see all the paths come back together, and that is if there's a path that leads to, you'll say the last slide has it. If there is one of the alternatives that represents exiting the activity, even though there are other things being done, then you'll put there's another type of node called a flow final node. So you have an activity final and you have a flow final. So sometimes, if it is that there's nothing else to be done, or that particular pathway doesn't lead to anything else in the rest, doesn't need to join to anything else in the rest of the activity, then you just put a flow final node. And you'll see it at the end. So for instance, let me think of an example for that. Let us say, if you said that, okay, if somebody fails an exam, let's say the options are student must either pass the exam with an A, pass the exam with a B, pass the exam with a C, or fail. And you test for those conditions and you determine that for passing with an A, the student will get, maybe some award and then continue the program. B, they get a little certificate and they continue the program. And C, they get a warning and they continue the program. Then those three things must merge together and continue with the other activities other actions within that program. But if the person who fails is now being told that they cannot continue, then that path may not join the future actions. And in that case now, we're talking about flow final. So you can stop that flow. No, that is used. That's a connector. But you see, flow final is a circle with an X in it. Yeah. All right, let's continue. So we spoke about decisions and merges. Decision nodes are when you want to yes. Somebody has a question? Somebody online trying to say something? Right. Decision nodes are used when you want to execute a different sequence of actions depending on a particular condition which we saw. We saw how it's represented. Generally, there's one incoming edge to a decision node, and then you have multiple outgoing edges. Each branch edge has a guard condition. So every branch edge must have a guard condition. If there is no guard condition, then we must be able to distinguish exactly. You don't want to leave an ambiguity as to what is the path for that branch. So statements evaluate either true or false. If true, the branch is taken, otherwise it's not. Now, what does that mean? One of the things that's implied by this is that you cannot have branches whose, you cannot have conditions where, or you can't have branches with conditions where more than one of the branches will have a true condition. Only one should be true at any given point in time. So if you look at this example, and tell me if you notice anything with it. So we have word count equals 0, notify block entry, notify block entry can't be empty. If word count greater than 0 and word count less than 1,000, save block entry. And the third one says word count is greater than or equal to 1,000. Then notify block entry too long. Is that okay? Yes. Word count, what's wrong with it? Is something wrong? I can't hear you. No. The main thing I was just looking at is whether or not all these conditions are mutually exclusive. Yeah. They are mutually exclusive. Okay, good. So there's no chance of you having word count equals 0 while having word count greater than 0 and word count less than 1,000. Those are mutually exclusive, and then we can check the other one. Word count greater than or equal to 1,000. That should also, all these things can happen independent. Let's look at this one. What's wrong with this one? Sorry, I keep forgetting that you're not seeing the slide. Everybody can see it online, right? So look at the next slide, the slide that has item in stock, item out of stock, rush order. Can you see that? Yeah. Right, everybody sees that? So these are not things that will necessarily be mutually exclusive in every single situation. So it means that you have introduced ambiguity into your activity diagram. How can we correct that? Sorry. How can we correct that? If we want to be able to pick only one pathway where item is in stock and there's a rush order, or item in stock and there is no rush order, and so on. Yes.
Equal to conditions is in stock and out of stock. Merge in a small diagram and then.
Right. We can check one of the conditions. We can check one of the conditions first, and then merge, and then check not merge. We can check one of the conditions on each branch. We'll check the other two conditions with two new decision points. So that's one option. So there are two options here. Move to the next slide and look at the other two options. Look at the two options. So in one case, we have we use two conditions for each. Two conditions for each test. So on one side of it, so we end up with 4 branches. Item in stock and rush order, item in stock and not rush order, item out of stock and rush order, item out of stock and not rush order. That makes sense? Right, it makes sense. I probably would write my activity diagram like this. So there's another option. Everybody seeing the other option? So we can check for item in stock or item out of stock. And then based on which branch you take, then you can check for rush order or not rush order. And also, instead, notice that we can use the else on the as a guide condition as well. But another way of doing it is just simply saying for this one, so for example, with item in stock, where you have a decision node, that branch, first branch could be rush order, the second branch could be not rush order. So you can do that as well, that's fine. And then there's fork and join, which we spoke about on Monday as well. When do we use a fork? When we have different actions that we want that happen simultaneously. What else? Is that everybody agrees with that definition?
Yes, miss.
I heard the first part, but I didn't hear.
When we need the different actions that are happening to join to one merge.
Okay. Yes.
When all of three conditions meet, but give me an example of each true for you.
Right. That's actually a good explanation. So what you said, Ronaldo and lawyers, those two things are true. The main thing is not necessarily that they must be happening exactly simultaneously. So even if you don't have threading, like multi-threading or multiple processors to allow literal parallel processing, the main thing is that these are things that need to be true. These are things that need to be done before you move on to the next set of things. So it's really a set of actions that need to happen before you move on to some other things. So even if they don't happen at exactly the same time, you want all of them to complete before you can do anything else, then you consider them to be things that need to happen or can happen in parallel. So one of the things that you need to think about with the use of a fork is that if you do a fork and then you say you have action A, action B, action C, and they are on different paths, of course, you cannot move on unless all those three actions are complete. So even if A completes first and then B and then C, you need to wait for all of them to complete before you move on to the other one. So let me just go back to you. Okay, so after forks, so forks and joins are used in activity diagrams to illustrate parallel actions in an activity. After a fork, the flow is broken up into multiple simultaneous flows. Various actions may take place on these flows, but they happen in parallel. The join means that all incoming actions must finish before the flow can proceed past the join. So it may be that they finish at different times, but using a fork and join means that you can't do anything else until everybody else. You can't go past the join until all the processes, all the actions behind it after the fork are finished. The join means that all incoming actions must finish before the flow can proceed past the join. Fork and join are both indicated on the activity diagram with a thick bar, but the fork has one incoming flow and multiple outgoing flows, while the join has multiple incoming flows and a single outgoing flow, similar to the decision and merge. So in this case, yes, go ahead. Not conditions, it's all the actions that are after the fork must complete before you can move on to the join and do the things that follow.
What if all actions are true?
It's not really true and false, it's complete or not complete. Then it means that the system, at least that particular flow, is permanently halted. So you have to think very carefully about how you put things in a parallel, what are things they include in a fork. Because if there's one of those actions that is not written properly or is not designed in such a way that it says, well, this is how complete. If there's something that can stop that action from complete, that would mean that the diagram probably is not so accurate. Now remember that although the activity diagram is not a representation of the it doesn't necessarily translate line for line or action for action into literal code. It does indicate to the designer some of the ideas that you are trying to put forward in terms of what the system design. And so yeah, you want to think about those things. Does that make sense to everybody?
Yeah.
If, for instance, looking at you know, in A and C that happen in parallel. So you use a for, and you put those three flows there. And then you say, okay, afterwards they'll join and then you go on to the other things and so on. If one of them is dependent on some other action or some other system or some event that may or may not occur, then you need to control within the description of that flow what are the actions to take on if this particular event doesn't come through in order for it to move forward. No, you just, so remember, you know, that activity flow, let me see if I can find one that has many steps in it. A flow can have many steps in it. The flow can have many steps in it. Remember that the flow, so when you do the activity diagram, the flow can, a particular flow, like let's say right here we have prepare case, right? So you're only seeing one action. Are you seeing the slide that shows the second slide in the fork and join example? So it shows prepare case and prepare motherboard after a fork, and then you have some other activities, right? This is very, very, very simple. But any one of these flows, for example, prepare case could have many different steps inside of it. So it could have many actions, it could have decision points, it could have events, it could have timed events and so on. So you can put a decision that says, you know, if such and such an event is not received by a certain time, then do something else. Yeah. Not instead of, it's not really instead of, they're two totally different things. One of them says, a decision, Diamond says, only one of these paths is valid based on a particular condition. A fork says, all these paths are valid, and they're going to happen simultaneously, or they're going to happen during the same time period. That makes sense? Yeah, so they're very, very different. And as I said, you want to be very careful. With the decision, you want to make sure that you do have mutually exclusive guard conditions on each of the branches. And with the fork, you want to make sure that you're not going to have an action or a series of actions that don't lead toward the end of don't get to the join, because then none of the other flows will exit the join. So even when parallel actions do not complete at the same time, that is, parallel flows arrive at the join at different times. The flow following the join will not begin until the parallel flows arrive at the point of the join. So here's a question. Do we also have to show a join after a fork? Do you always have to do it? So for example, if it is that you have a join, and right after that you want to facilitate another fork, and there are no actions in between, there are two different ways that you can represent it. The main reason why I have this here is because this was a question that some students had a few years ago, and I just thought it was good to just show the example. There are times when you can use the bar as, it depends on style, but you can use the bar as both a fork and a join. Can everybody see the example that says, do we also have to show a join after a fork? This should be always. Can everybody see that with the two? Right, so you can have the join and then put a flow, an activity flow line, and then put another fork and proceed. Or you can just use the same one. Time events. Now, events are things that happen outside. Again, events are things that happen outside of your system, but your system needs to respond to. How do you show that in your activity diagram? So the first type of event we're going to talk about is a timed event. And a time event is drawn with an hourglass symbol. Remember, we use the hourglass symbol as well in the use case diagram? Right, so we can also use it in our activity diagram. So in this, you have two examples here. One that shows ship order as the first action, and then we see an hourglass with a label on it that says wait 3 days. So it means ship the order, then wait 3 days until you, and then you send the bill. Another thing that you can do is you can use time events to initiate or to start an activity. Generally, we would use the initial node, that's the circle, the black circle, to indicate the start of an activity. But if you use a time event at the beginning of an activity, it automatically indicates the start of an activity that is initiated by the expiration of a certain amount of time. It also indicates that this activity is a repeated activity. So in this example, we're seeing update progress bar as the action. And what it means is that every 1 second, you update the progress bar. Yes, Ronaldo? It means that the system is, yes, it means that your system is actually, yeah, it's kind of like the system is waiting for something to start. So that's what it would do. Calling other activities. When you have, remember, we spoke about creating an activity where we put a frame and name the activity and then being able to reuse that activity in another situation. So look carefully at the diagram on the next slide, which says calling other activities. There are 2 diagrams there. Take a look at the first diagram, and do you notice a new symbol? There's something there that looks like a rake or font. Everybody seeing that? So prepare motherboard has a little fork, a little rake thing on it. And that's used to indicate that prepare motherboard is actually an activity that is defined in detail somewhere else, and you're reusing it in this particular activity. Everybody seeing that? Great. Object nodes. Remember we said that we don't really use activity diagrams to show the flow of data or objects. So on those arrows only represent this thing is first, then this thing, then this thing. It's only representing the ordering of activities. However, sometimes we want to show that not only is thing A happening before thing B, but that when action A completes, it sends a particular object or particular data or particular information to action B, and action B needs to use it, right? So there are different ways that we can show that. And I'm going to just go straight to the diagrams because we can get all the details from talking about the diagrams. So if you look at the first diagram on the alternative representations, everybody seeing that on the next slide, alternative representations? Can everyone see that? Good. The first diagram, what's happening there? First action is we receive an order request. Everybody seeing that? And then we'll see a rectangle being introduced. So that rectangle represents an object. And the object doesn't have to be a software object. So it doesn't have to be an instance of a class. It can't even represent, because remember, this is very high level. So it can't even represent, like in this case, it says an object node. It just represents, sorry, well, it says object node, but it says order. That's what I wanted to say. So it represents an order. It could represent a paper order. It could represent the order on paper. But the point is that you're just trying to indicate what is it that's happening in this particular activity. So in this case, it means that an order is produced and passed on from the receive order request to the approved payment action. Approved payment is going to get this order. So once you have an object node and you have an arrow coming out of it, it means that the object is going to the next action. So the arrow coming out of order is saying order is being passed to approved payment. Does that make sense? Make sense? Okay. And then approved payment does, whatever steps are inside of it, and then we're going to submit order. But there's an alternative notation, and I kind of like this one. Same point is being made here, same exact activity. We have receive order request, and then we have a little pin. It's called an output pin. Everybody see that? There's a rectangle, a little square box sticking off the receive order request. It means that there's an object. That is being that's being passed by the particular action. And then we'll have our arrow, and then we'll see an input pin. And the input pin indicates that there's an object being received by this action. Get that? So if you have a pin on the right hand side of an object, then it is an output pin. If it's on the left hand side, it's an input pin. And you would have to use a note to indicate you'd have not a note, you'd have to use a label to indicate what's the name of the object. 1 minute. Another thing is that you can access a part of an object. So in this case, you're seeing an example where the cost part of the order object is being shown. Everybody got that? So the order object is being sent by the receive order request. But it is the cost aspect that is being required by the approved payment action. Make sense? All right. It can be attributes, yeah. It can be features that you want to indicate that, that's what is being used. Another thing that you can represent within an action, within an object, is the state of the object. And again, we use all square brackets to indicate the state of an object. So in this one, you can see at one point the order has a pending state, at another point the order has an approved state. And when you want to frame an activity, remember that they're active, remember the frame, we usually show that we want this activity to be reusable. Now, supposing that you want to indicate when you're designing the activity itself, you want to indicate that this activity receives some input and gives some output. Then you can show that on the frame. So on the frame here, do you notice that there's an object right at the beginning, and it etches out a little bit, and an object right at the end. So it's basically saying when you reuse the approved payment activity, when you reuse an approved payment activity, you receive an order, and you will be able to send an order at the end. Yes. What? It's not like using fork. We'll talk afterwards. I think we will just have to continue with this next time. I want you to look at signals. Sending and receiving signals. It's pretty simple, but I know that sometimes you might get confused. So you can look at that, and there are some examples associated with it. You can look at that, look at the examples there. And then there's partitions or swim lanes, which is another useful feature of activity diagrams. All right. Okay, people online?
Yeah.
Yes, miss.
You.
Okay, people online. Thank you very much. Bye-bye. Have a good day.
Bye. Bye.
Bye, miss.